So in this video, we're going to talk about some symmetry properties, which is complementary angle in the unit circle, and also we're going to talk about the Pythagorean identity as well. All right, let's get started. So what do you have? Complementary angle first um, is when two angle that the difference between two angle is 90 degrees or 270 degree or multiple of that. Okay, so two angle that has the sum or difference of 90 degrees, 270 degree, and so on. All right. For example, you might have something like 30 degrees, and if you do 90 minus 30 will be 60. So 30 degree and 60 degree are complementary to each other. So we're going to learn the relationship between these one. All right. So if you look at the unit circle here, you can see here is the angle theta, the y value, the vertical, which is the psi value. So this represents psi of theta. B is psi theta, as you can see here. Okay. Now, if we have another angle, so you go from zero. If you go this way, that's 90 degree, which is pi over 2, right? Now, theta is that much, isn't it? Now, with the same degrees, the same amount of angle from pi over 2, if I go backwards theta, I'm going to have pi over 2 minus theta, which is this angle right here. Okay. Now, as you can see, this triangle here, so you see this triangle and this triangle, they are congruent, so they're the same. So what does that mean if they're the same? So as we say, if we talk about comparing the side, this vertical distance here is actually the horizontal distance here, which is B here, the bow equal B, right? So, but the vertical distance here is sine of theta, okay? And the horizontal distance here, what does that represent? This is for the angle pi minus theta. And the horizontal is the cos value. So this is cos of the angle, cos of pi over 2 minus theta. So you can see they technically the same value. Therefore, we got this equation here. Cos of pi over 2 minus theta is the same as sine theta because they both equal B. Similar logic, we can do the same thing for sine of pi over 2 minus theta equal cos theta. So why does that happen? If I do again, but this time I'm going to do so I'm I do the opposite. So I have the angle here, right? So this horizontal is letter A. This represents cos of the angle, cos of theta. Okay. Now I is horizontal here, which is the same as you can see. This is answer I. So this is the vertical distance and the vertical distance of that angle. So this will be psi of that angle. So psi of pi over 2 minus theta. So they both the same. Therefore, we have that psi of pi over 2 minus theta equal cos of theta. All right, with similar logic, we can derive the same formula if we have to do sine of pi over 2 plus theta. So you can see pi over 2 plus theta is in the second quadrant, right? Which is, we're not talking about sine, so we're talking about the vertical distance. So we're talking about that distance here. That's sine of pi over 2 minus plus theta. And if we compare to this triangle here, that distance is the same as the horizontal distance underneath here, which is A. And the horizontal is cos of the angle, but the angle we have here is theta. Therefore, sine of pi over 2 plus theta is cos of theta. Okay. If we do the one on the bottom, what we have is if we have cos of pi over 2 plus theta, so pi over 2 plus theta is here, we're looking about cos, so we're looking at the horizontal. So we're talking about this. And you can see this brings the negative value, right? Now, this distance is the same as this distance here, because the bow equal B. So this is the vertical here is psi of B, so psi of theta. The horizontal here is cos of pi over 2 plus theta. But and we talk about it's bringing a negative because it's on the left-hand side of the x-axis. Therefore, you can see cos of pi over 2 plus theta equal negative of psi theta. So the opposite side. So what do we learn from this one? For complementary angle, as you can see, psi value, you can see psi value will become cos of the original angle. So cos of one angle will become psi of the other angle. Sometimes there could be negative, but you can see here cos of one angle is negative psi of the other angle. So it depends on the question and it depends on positive or negative side or cos or tan value. So generally speaking, if you can remember this, and this is a strategy to work it out without actually memorize all of this. So side of one angle, okay, side of one angle, whatever the angle here, that will be plus or minus cos of the original angle. So we can say psi of x, let's go x and y. So psi of x will be plus minus cos of y if x and y are complementary. So basically, they are having the difference or the sum of 90 degrees or 270 degrees. The plus and minus you have to determine based on where x and y on the x-axis. And same, if you do tan of one angle, that will be the 1 over 10 of the other angle. So 1 over 10 y. And it's again, it could be plus or minus. Okay. Now, let's see how we're going to apply in here. All right. So here, let's say I want to do B. Okay. They give me psi of pi over 2 plus alpha. So first of all, I'm going to simplify this first. Okay. Now, and I do have the alpha here. Cos of alpha is 0.6, as you can see. Now, psi of pi on 2 plus alpha, and if I want to convert to alpha, they basically complementary because the difference is 90 degrees, right? So I know the answer is either plus or minus cos of alpha. That's what I know. I just don't know plus or minus. So how do I determine that? So think about alpha is in quadrant 1, okay? From alpha, you plus 90 degrees, which is pi on 2, which here, pi on 2 plus alpha. So for pi over 2 plus alpha, we're looking for psi. And in this quadrant, psi is positive. So we know that this is positive. Cos alpha in this quadrant is also positive. So of course they're both positive. So we don't have to have the negative there. Okay. So and then we just simplify that. So cos of alpha will be 0.6. All right. If I do, and let's say this time, I want to do another angle, just a different name. Let's say I want to do xd. So cos of pi over 2 minus x. Okay, so I know that the answer will be either plus or minus psi of x. Cos will become psi of the other angle. So I draw it out, all right? X in quadrant 1 and psi of x in this quadrant, psi of x is positive. Now, pound 2 minus x, I'm looking for cos. So pound 2 is here, and I go backward x. So that much. So this angle here will be pi over 2 minus x. And I'm looking for cos of that. So in this quadrant, cos is also positive. So you can see both of them is positive. So I don't have to do a negative, do I? So I'm going to delete that. It will be positive sine of x, which is, you can look at this, sine of x is 0.3. So I know the answer is 0.3. All right. Now, similar to, you can do pound two, or if I do another one, let's say this time I do 3 pound 2 minus theta. Okay. So here I have 10 of 3 pound 2 minus theta. I know the answer, as you can see, 10 will become 1 over 10 of the other angle. So it's either plus or minus 1 over 10 of theta. And I know 10 of theta is 0.7 right there. All right. I just need to know it's plus or minus. So think about theta is in quadrant 1. Okay, which is part 10 of theta will be positive for sure. Now 3 pound 2 minus theta. So 3 pound 2 is 270 degrees, which is right here. If you minus theta, you will have about there. Okay, so that's 3 pound 2 minus theta. In this quadrant, I'm looking for 10. 10 will be ASTC. In this quadrant, 10 is positive. So I know that this gives me a positive answer, and this 10 theta also positive. So I don't need the negative again. So I know that that's positive 1 over 10 theta. And 10 theta, they give me 0.7. So 1 on 0.7, which is 1 on 7 over 10. If you flip it, it's 10 over 7. All right. Now, about Pythagorean's identity, this, if you recall the Pythagoras theorem, if you have a triangle like this, sorry, this, let's call this is A, this is B, this is C. So Pythagoras say A squared plus B squared equal C squared. So on the unit circle, I have a triangle here. This is cos theta. This is sine theta. And because the radius equal 1, so that distance equal 1. So what do they say? If you apply this formula, you can see A is cos theta, B is sine theta, and C equal 1 for hypotenuse. So if I apply the formula, I would have cos theta squared, that's A squared, plus sine theta squared equal 1 square, right? And 1 square is just 1. Now, to write it nicer, they put the square in the middle of cos and theta. So we write cos like that. Theta square, sine theta square equal 1. So this is called Pythagorean's identity. And we can use that to solve for cos if we know sine, and vice versa. And if you look for 10, 10 theta will always be sine theta divided by cos theta. Okay. Now here I have the angle here, sine of x equal pi 3/5. They give me the domain where they are. They are occupied by cos theta. So I'm going to use the formula sine of x plus cos of x squared equal 1. And then I substitute in. So sine of x is 3/5. So I sub that as 3/5 and square that, plus cos of x squared equal 1. 9, 3/5 square is 3 times 3, 9, 5 times 5, 25, plus cos of x squared equal 1. Now you're going to take 9 by 25 over, so cos square of x equal 1 minus 9 over 25, which is 16 over 25. Now, to get rid of square, you're going to square root that. So you're going to write cos of x equal plus or minus root 16 over 25, which is plus minus 4/5. right? Now you have to determine is it plus or minus, and that depends on what you are given here, the where they are. The angle is, if I draw it out, they tell me it's between pi and 2 to pi. So pi and 2 here, pi here. So the angle x is in between these two. So in this question, cos is ASTC, right? So in the second question, cos is negative. So I know I pick the negative answer. So negative 4/5. That will be the answer for I. Now, if I look for tan theta, so it's a bit messy. So tan of x will be sine of x divided by cos of x. So sine of x is 3/5, cos of x is negative 4/5. Oh, sorry, 3/5 divided by negative 4/5. The 5 will go away. You have negative 3/4.